So first, let's start off with what's a prism. So the definition of a prism is that it's a three-dimensional figure. Oftentimes we call them tetrahedrons, like the game Tetris. They have to have two parallel faces, which are basically their surfaces. And those faces are called the bases, like in baseball. All the other faces or surfaces are always going to be rectangles. But the prism's name is going to be called the specific name based on the shape of its two bases. So let's figure out which of these figures here are prisms. So let's figure out first which ones aren't. So if I go ahead and look at this one, I see that I have a square right here. And so even though we can't see it and it's not three-dimensional, specifically because we're looking at a flat screen, if I was on the other side, would I still see a square? Yes, and it looks like a round, even though I can't see the bottom and the left side, it would also be squares. So that means, and we know squares are rectangles, so this meets the criteria of a prism. So this would be called a rectangular prism, but more for specifically, it's a cube. Now let's look at the purple one underneath. Now I see triangle here, and I see a triangle here. So if I kept going around, I bet I would see what else? Triangles. It kind of looks like the Pyramid of Giza. This definitely is not a prism. It doesn't have two parallel bases because these triangles are not parallel to each other, and I know that I have to have a bunch of rectangles. And if I'm going to have a rectangle, the only rectangle I have is at the bottom, which is 1. And that is not going to have a parallel side. Okay, so let's look at this one here. So if I look at that one, I see rectangle, rectangle, and I see a rectangle here, which means if I kind of keep going around, I'm assuming that I'm going to have 3 more rectangles. On top, I see 1, 2, 3, 4, 5, 6 sides, which tells me I have a hexagon. And I see 3 sides here, which tells me that most likely I have a hexagon at the bottom. And the bottom hexagon is parallel to the top hexagon, which means this is called a hexagonal prism. Okay, let's look at this other yellow one. So I see a circle. I don't see a rectangle at all here. And I'm assuming I have a circle on the bottom because it kind of looks like a can of soup or soda can. So this is not a prism. You probably know it as a cylinder. So we have a cube, which is a specific type of prism. We have a hexagonal prism. And let's see if this is a prism. So I see a triangle. I see a rectangle. I'm assuming that even though I can't see the side, it kind of looks like a tent. And I've seen tents like these, and I know on the other side is another triangle. And that triangle is going to be parallel to the other triangle on the other side. And when I've seen tents like these, I know there's another rectangle on that side. And the bottom or the floor of the tent is a rectangle. So that means all of the 2 parallel sides are triangles, which means those are my bases. So this is a triangular prism. Okay, and then the last one we have is this red thing right here, and it looks like a box. And pretty much if it looks like a box, it's definitely a rectangular prism. We don't even have to worry about it because it looks like my favorite type of boxes, which we'll be looking at in a moment. But when you're looking at a rectangular prism, it doesn't matter which side you go ahead and use as your face, because you could use this side as your face and then its opposite side as the other face. Or, I'm sorry, I said the wrong word. So when you're Now, when you're looking at a rectangular prism, it doesn't matter which two sides you use as the bases. You can use this side as the base and its opposite side as the other base, or you could use these two sides, okay, or the other two pairs of rectangles. And that's because since all the sides are rectangles, it doesn't matter which two sides are your bases. But it does matter if you have a hexagonal prism or a triangular prism. Now, what we're trying to measure today is a surface area. So what are you going to do when you're trying to measure the surface area? Well, the definition of surface area is it's the sum of the areas of the faces of the tetrahedron, which is a 3D figure. So it doesn't matter what kind of, it could be a sphere, and we still could measure the surface area of it, even though a sphere only has one face, because it's one smooth spherical surface. So here's a box from my favorite company, Amazon. It brings me lots of wonderful things. But how does that box start? How do they figure out how much material goes into making this box? Well, when Amazon orders the material to create these boxes, they have to start, the company that makes them starts off like this with sheets of cardboard. And so they have to get the correct sheet of cardboard to make the different sizes of the boxes. And so knowing the surface area that they need, or what size cardboard is going to make the different sizes of boxes, is what goes in to figuring out how much they need to get to make a specific size of box, because it's the outside that they need for the cardboard. Now what goes inside is a different measure. That's volume. So the people on Amazon have to worry about two measurements. They got to figure out how much surface area they need, or how much cardboard they need to create a box, based on the sizes of the boxes that they need to fit a specific volume of materials that they need. And so things like this, a tent, they too actually start with some materials. And so here's how a tent starts, with a bunch of rolls of material. And so before they go ahead and cut the material, they need to know how much vinyl that they need. Now, a simple pup tent was actually probably the oldest style of tent that was ever used. It's been used probably since the Roman times. And that's because you could make it by using two sticks and some string across the top, and you could just get some simple cloth materials, and you could go ahead and you could get it over. And so by knowing just some simple measurements of two sides that you need for it, you could get it. Now we're a little bit more advanced and we can measure a little bit better, but surface area tells us exactly how much vinyl we need so that we don't have to sleep on the wet ground, which would be the bottom part. We don't get wet, which is these two sides here. And the mosquitoes don't eat us, so we have the sides in the back and in the front to keep the mosquitoes out. Okay, so now let's actually calculate the surface area. So to calculate the area of the surface area of the entire prism, we have to figure out the area of each of the faces. Now the problem is not every single prism has the same exact number of faces, but it's pretty easy to figure out how many there are based on the base. So let's kind of count. So here I have a cube, and I know that a cube has a base, that's a square, and a square has 1, 2, 3, 4 sides. So I know that if I have a base that's a square, I know that there's two bases, and I know that for every side of the base, I'm going to have one rectangular face. So that means I have two bases plus 1, 2, 3, 4 faces. So I have 6 areas that I need to measure. But the good news is, because my base is equilateral and my height is the same as the measure of my base, for a cube, it's actually pretty easy to calculate. It gets a little more complicated when I have a figure that's a little kind of wacky. Now, one of the things that really helps you to kind of figure this out a little bit easier is something called a net. So here's a really short animation, and there's our cube. And it's kind of like we're opening the box, and the cube's inside, and we're laying out each side onto a flat surface. So let's go ahead and look at so here's our net. And what we know is that because this is our base, each side is 5. And because these are all squares, all of them are going to be 5 by 5. So if I go ahead and I wanted to figure out what's the area of a square, we know that for area of a square, it's side squared. And in this case, my S's look like 5s. I would replace the S with a 5, square it, and I get 25. And so if all of these have an area of 25, and they happen to be 6 of them, what's a shortcut for adding 6? What's a shortcut for adding 25 6 times? Well, I could go ahead and say 6 times the area of the square is equal to the surface area. So, since the area of the square is 25, my surface area would be 150 centimeters squared. So a cube happens to be one of the very few figures where we have a very specific formula. So the area of a square is equal to side squared. So the surface area of a cube is equal to 6 times side squared. Now, again, doesn't hold true for every other one. So let's go ahead and look at what we would do for other figures. So our ultimate goal for every time we want to figure out the surface area is we have to calculate the area of each face or side of the figure. Sketching a net can help us to visualize the dimensions of each face, which can help us with calculating those areas. So specifically, when we're doing that, this is what we need to do. We're going to have to determine what the bases are. By knowing what the bases are, we know what kinds of formulas we're going to need to calculate the areas of those bases. And then we need to know what's the number of faces we need. Because remember, those faces that are going around the prism are all going to be rectangles. And so if we know what our two bases are, and we know what the face, how many faces we're going to have, then we know how many things that we need to add up to get our total surface area. And then we need to know what their dimensions are. Once we know that information, we're going to go ahead and use formulas if we need to figure out the area of each face. Then we're going to find the sum or add up the areas. There's times we're going to be able to take some shortcuts because, for example, we know that our two bases are going to have the same exact areas, so we don't have to calculate it twice. And a lot of times, Some of our faces may even have the same exact areas, like in a rectangular prism. So we may be able to combine some and use shortcuts so that we can go ahead and be able to combine some rather than just add and add and add. Okay, so let's go ahead and practice. So here we have two prisms. So let's name them again. So we remember this one is a So this one up here is a rectangular prism. And the orange one is a triangular prism. So let's look at the rectangular prism first. Now, if you're going to try and draw a net, which I recommend, you do not have to do it very nicely by dragging out a ruler or anything like that. As you'll see, mine are pretty ugly. The important thing is just go ahead and think about how many sides there are. So in a rectangular prism, you're usually going to be seeing it so that you see 3 of the rectangles, but there's actually always going to be 6. And the 3 that you see are always going to have 1 matching. And so I have this really big one. And I see that it is 25 by 18. So on the side, it's 25, and this is 18. Then I have this long rectangle attached to it, but it's kind of narrow. So that means it's 25, and it's got 4 over here, so that means it's 4 on the other side. Okay, and so if I was to go ahead and I was to look on the other side of that box, I would see another one that is 25 by 18. And then on the bottom, I would see one that is 25 by 4. Okay, so then I have this one that's right here. And so I see this is the 4 inches. So I could draw it right here off of this one. And so it's 4 inches by 18. So 4 by 18. And notice this 18 touches this one, which is 18. And then I would have another one down here, which is 4 by 18. Obviously, not a work of art, but it's good enough, right? Okay, so now I can easily go ahead and use my calculator and find the area of each one. So because these are all rectangles, I'm using the area formula for a rectangle, base times height or length times width, whichever one you want to use. And I'm going to go ahead and I have 2 that have the same area that are 25 by 18. So I'm going to put times 2 because there's 2 of them. So if I go ahead and I multiply 25 times 18 times 2, I get 900. And then I have 2 that are 25 by 4. So if I go ahead and do those, I have the area 25 times 4 times 2. 25 times 4 is 100, and 100 times 2 is 200. And then I have 2 that are 18 by 4. So 18 times 4 times 2 is 144. So now, last step is find the sum of all the areas. So I add 900 to 200 and 144. So 900 plus 200 is 1100. 1100 plus 144 is 1244. And what's our unit? It's area. So area is always in inches squared or whatever units squared, but for this one it would be inches squared. Okay, now let's look at how we go ahead and do this with a triangular prism. So let's look at our triangular prism. So we know that in a triangular prism we have two faces, or that are called our bases, that are triangles, and the other faces are going to be rectangles. Now, you see those little tick marks that are around, like here? Remember, those are called congruency symbols, and they mean that those three sides of the triangle all measure the same. So if the bottom one measures 1.5 meters, that means this side here measures 1.5 meters, and that side there is 1.5 meters. But notice that 1 8/10 meters is pointing to the height of the triangle. So let's go ahead and figure out the surface area. So this is kind of like our tent. So if we were going to go ahead and figure out our surface area, we would first want to go ahead and let's make our net. So we know that if we went ahead and made this roll out like a tent, it would look like 3 rectangles. So let's draw 3 rectangles. And they're all the same size because this measures 1.5 meters and this measures 3 4/10 meters. This is the same and this is the same. So they're all 1.5 meters by 3 4/10 meters. Okay, and then they have a triangle that's hooked off of them. So I'm going to draw my triangle, hooked off, and I'm going to draw my height of my triangle, and I'm going to show that the height is 1 8/10 meters. So now I'm ready to do my surface area because I can see all my faces, and there's 5 of them. So I know I need to do the 2 triangles. So I need to do the area of the triangles, and since they're congruent, I know that I'm going to need to double whatever I get for the area. So I'm going to do times 2. Remember, this times 2 is because I have not 1, but 2 of the same. This is coming from my formula. Okay, so my base is 1.5. My height is 1 8/10. Divide by 2. So that's my first step, find the area. Okay, and then remember I'm going to double it because I have not 1 triangle but 2, which gives me 2 7/10 meters squared. So now I'm going to do my area of the rectangles. So rectangle is base times height, and I have 3 of them that are congruent. Because I have 3 of them that are all congruent, and don't assume always that they're always going to be congruent, because we could have a triangle that is not isosceles or not even equilateral. So we're going to go ahead and put in our dimensions, which is 1.5 meters times 3 4/10 meters. And then we're going to multiply it by 3. So 1.5 times 3 4/10 gives us the area of 1 is 5 1/10 times 3 is going to give us 15 3/10 meters squared. So the surface area of the prism is going to be the sum of the faces of the triangles, bases, the rectangular faces, which gives me exactly 18 meters squared. Okay, and we'll work some more in class. Thanks.